So if you want to leave your cameras on, you'll be on the Facebook stream. If you want to shut off your video, you will be hidden from that for the moment. It's entirely up to you. We'll be starting the webinar at 8:30, about 7 minutes. Thank you to all the attendees for sticking with us for this check-in process. If you're just joining us, we'll be starting in about 7 minutes. We're just waiting for one additional team to finalize the check-in process. I'd like to say a special thank you, welcome to a few of our international site directors. We got Dr. Romero on board, he's on the attendee list, and Jocko Van Week from South Africa. Thank you for joining us this morning.
All right, I have a just a brief announcement for the judges. Just want to make sure you're aware that this is the format we'll be using when we introduce you. So just name, affiliation, and then any professional career or expertise that you would like to highlight. So thank you. All right, Shannon, I'm gonna relabel homies again.
Okay.
This is their second camera, right?
The Dania Bashi.
Uh-huh.
Yeah. I don't know what's going on with them.
Okay.
I suppose since they're last, we can help them at the moment. They need to do any last minute checks. So, homies, if you can hear me, we still would like to check your screen sharing and audio visual. If we don't get a chance to check that before we get started at 8:30, we will check it before you start your presentation. You are last on the list, so we do have a little bit of time. Hopefully, if everything moves quickly and smoothly, we'll be a little ahead of schedule. So we'll be moving all of the team's second cameras over to the attendee list. So if you would like to get started, it's about 8:26 right now a.m. So everybody who is presenting, all the teams, if you could turn on your main video. That way we can move all of the secondary videos over appropriately, and then we will during the opening ceremonies, we're going to take a group image, a photo for our publications and our presentations. Thank you so much for joining us. So if all of the judges and teams could turn on their cameras, we'll get ready to start the presentation at 8:30. We've got about 3 minutes. So I'm going to move all the second cameras over to the attendee list. Just so we have the main cameras showing. I think I got them all.
Okay. Oh, you're going live already?
Yeah, I started that a few minutes ago just so I didn't have to.
Yep. That's right. I remember.
I think I just did the wrong Garuda.
Okay. You want to bring them back?
Let me get them back. Because they're not. Okay. If everyone could turn on their videos, are you about ready to start?
Okay, ready?
Almost. We got two. The Garuda team is not here. Is she not joining us until later? Is that what's going on?
No, they should be coming. Yeah.
Oh. And then we've got 3346, the team from Hong Kong. They could turn on their video. And the two teams from Saudi Arabia, if they could turn on their video. We're missing 3 teams videos.
Yeah, that's okay. Okay, I think we can start then.
Okay.
Start recording.
Are you recording?
Yeah, you can too.
Okay.
Welcome everybody to the Robofest Online World Championship Exhibition Event, Senior Division. Thank you so much for joining us today. My name is Elmer Santos. I am the Robofest Assistant Director and also the competition chairperson for the exhibition events. Also with us today are Professor CJ Chung, founder and director of Robofest, Shannon Polonis, Robofest coordinator, and Daniel Oliver, who will be serving as our official timer today. Thank you all teams for checking in. A note to spectators, we suggest you join us via the Zoom webinar. This gives you access to the Q&A function and the quality is better. If you have joined via Facebook Live and would like to switch to Zoom, there's a link in a recent post that you may use. If you are in the webinar, any questions can be asked to the teams using the Q&A function. Questions must include team ID and team name. And then these Questions will be sent to the teams after the event. At the end of today's event, Q&A questions will be summarized by staff and submitted by email, and teams' answers will be used as well. Robofest is a program of Lawrence Technological University. We would like to thank our sponsors for their support. Denso, Michigan Council of Women in Technology, RoboMatter, NDIA, Real Time Technologies, Sortec, IBM, IEEE, and Toyota. Thank you so much for your support. The exhibition event is an event in a series of World Championship events for the Robofest Online World Championship. Please also join us for the bottle sumo and game events, which will be coming up in future weeks. This is our schedule for today, and we are going to have some opening remarks from the president of LTU.
Greetings, friends of Lawrence Technological University all over the world. We welcome you to the first ever Robofest 2020 Online World Championship, the only robotic competition in the world this year. I am Virendra Modgil, President and CEO of Lawrence Technological University in Michigan, USA. As you know, Robofest is all about STEM, science, technology, engineering, and mathematics learning. Success at Robofest requires mastery of multiple STEM and computer science subjects, which in turn drives preparation for college classes and high-tech careers. Additionally, Robofest teaches students to develop soft skills such as problem solving, teamwork, creativity, and communication. This year marks our 21st Robofest season. 2020 will be unforgettable. Due to the coronavirus situation, all the qualifying and regional competition around the world were abruptly halted in early March. However, we did not want to halt the learning opportunity for students. LTU's Robofest created new modality in the competition-based learning environment to cope with the unpredictable future rather than canceling it. So thank you for your participation in this new, unique, and different format of competition. I commend all of the teams and students here for being active learners and pioneers who are eager to master technologies for the future. As you may know, Lawrence Technological University was founded in 1932 with the support of the auto pioneer Henry Ford. At that time, Ford's famous Model T factory was at the forefront of an industrial revolution that changed the world. Likewise, we are at such a forefront of new technologies today. LTU and Robofest are paving the way. Someday, I hope you will join us here at Lawrence Tech to continue to do the excellent work you are already doing with L2U's Robofest. Your efforts are advancing science and technology for solving real-world problems. At this time, I would like to thank all the teachers, coaches, mentors, and parents. You make this program possible for our students. Without you, teams do not exist. Additionally, I would like to thank all of the inspirational international directors who have organized local qualifying competitions or are sending teams to Robofest 2020 Online Championship. Finally, we cannot give enough thanks to Robofest local judges and LTU judges for their dedication and volunteerism. Let us give all of them a round of applause. In closing, I wish all of you luck with your endeavors today and hope you have a great connected learning and collaboration experience. through this unprecedented online Robofest 2020 competition.
Okay, next we have some introductions and some announcements. This will be the presentation order for today. So teams, please take note of your position in the order, and welcome teams. These are our judges for today, and I will let them introduce themselves in just a minute. So welcome judges. How the judging will work. Teams have provided video links as well as source code files for review. So judges have been looking at those and have an idea of your projects. Today, each team will have 4 minutes to present and demonstrate their robots. This will be followed by a 2-minute question and answer period. Teams must use English for all communications. Judges' questions may be translated at the local level when necessary. However, answers must be directly in English. Judges may also ask additional questions by email to teams within 24 hours after the competition, and then teams must provide an answer back to the judges within 24 hours. And then, yeah, I will be the one coordinating the questions, so questions will be sent through Elmer Santos. And note that the rubrics for the online version of the exhibition style are slightly different from previous rubrics. Next, I would like to have each judge introduce themselves. Yeah, 1 minute.
Gonna just go in the order of our names.
Yes, thank you. Yeah, John,
Okay.
Go ahead. Start.
Yeah, hello everyone. My name is John Arnold. I'm calling here from Detroit, Michigan. I work for IBM. I am a client partner responsible for consulting services for aerospace and defense customers. In my history before IBM, I worked in aerospace as an engineer developing aircraft engines, and have my background is in engineering. So I'm excited to be involved with Robofest over the past 3 years, with Robofest and with Detroit Public Schools getting involved in youth robotics. So I'm really excited to be part of this kind of virtual event and finding new ways to innovate and be able to bring everybody together. So thank you.
Thank you, John. Next up, we have Mr. David Carberry.
Good morning. My name is Dave Carberry. I graduated from Lawrence Tech with a Bachelor of Science in Electrical Engineering in the inaugural university class, which is pretty great. Since then, I've been working at Fanuc Robotics. I'm now in product development, working on industrial robots. I've helped out as a coach and as a judge with Robofest for several years. Wish that all the teams today best of luck.
Thank you, David. Next up, we have Mr. Ben Gonzalez.
Okay. Good morning. I'm Ben Gonzalez. I'm also a graduate of Lawrence Tech with my bachelor's degree in electrical engineering. Since then, I had gone into aerospace, worked there 5 years, worked at Ford Motor 25 years. During that time, I was sent to school and acquired my master's in electrical engineering at Wayne State, my MBA at the University of Detroit and the University of Amsterdam in Holland. And have since gone on to work currently with Hitachi doing ignition electronics and also looking at the next step of gravitating from conventional combustion engines into electrification strategies with architecture. Thank you. Very happy to be part of this.
Thank you for being with us. Next up, we have Dr. Wei Liu.
Hello, everybody. Good morning. And this is Wei. I have been involved with Robofest, I think for 9 years now, as a coach in both, junior, senior teams in many events, starting from the Robo Dance, actually. So I also involved in the WRO, World Robot Olympia, through the Robofest. And I received my PhD degree in the mechanical engineering area and worked in CFD companies in Japan and the USA. Currently, I'm working for the Toyota Research and Development Center in Ann Arbor in the model-based department. I'm very excited to be part of this historical event. Good luck to every teams here. Thank you.
Thank you. Next up, we have Dr. Yanlu.
Hello, I'm Yanlu. I have been working for Toyota Technical Center for 17 years. I'm doing computation fluid dynamic analysis on vehicle, on HVAC, and my job is related with the external aerodynamics simulation and also for heat and transfer simulation. I followed my two boys, join Robofest activity more than 10 years. I served as a judge a couple of times at Robofest game and the exhibition category in Michigan and the World Championship. And also I did a judge for advanced robotics competition category in 2015 World Robotics Olympiad final in Sochi, Russia. I'm so excited to join this activity online. Good luck for all the teams.
Thank you. Next up, we have Professor Wuming Jing.
Hello, everyone. I'm Wu Ming. I'm working at the faculty here at Lawrence Tech. My major interest is in mechatronics and a very tiny, small-scale robotics. It's very exciting and challenging, and very glad to be here to seeing you youngsters to working on some interesting projects you like. Right? Good luck. Mm-hmm.
Thank you. Next, we have Mr. Morgan McCann.
Good morning. My name is Morgan McCann. I'm coming here from Royal Oak, Michigan. And I graduated from Lawrence Technological University in 2018 with a Bachelor's of Science in Mechanical Engineering. And I'm currently working on a master's degree in Mechatronic Systems Engineering. I've been a participant in Robofest ever since I was in 6th grade, around 2005. And I transitioned to being a judge in 2012 when I graduated high school. And ever since then, it's been a wonderful time judging. And I'm currently working at General Motors as an autonomous camera imaging development engineer.
Thank you. Next, we have Ms. Andrea Meister.
Hi, everyone. I'm Andrea Meister. I have been involved in Robofest since 2007 as a participant, judge, intern, etc. I currently work in supply chain robotics at Vecna Robotics in Boston, Massachusetts. Good luck to everybody today.
Thank you. Thank you again to all our judges. As a note, their bios are available on our World Championship page. Also, I would like to note that I will be functioning as the judge coordinator today. I will be helping coordinate judges' questions, but I am not a judge today. Okay, it looks like it's time for the group picture. All right, so can everyone turn on their cameras and come close to the camera so we can get some pictures?
Just waiting for the one more team.
Okay.
Powerpuff Nerds. Homies, can you turn on your camera too, just for the photo, and then we'll get started? There you go. Great, thank you. Powerpuff Nerds, are you there? Okay, we're gonna go ahead. Unfortunately, we need to keep moving along. So Pam, are you ready? Powerpuff Nerds, can you turn on your camera? I see you chatted back to me that you are there. Can you just turn on your camera for the image?
There they are. Oh, you're muted, Shannon.
Keep smiling, everybody. Pam's going to take a few pictures. Take a couple more, Pam. Okay, we good? Okay, I see a thumbs up.
Thank you very much, everybody.
Thank you.
This may be the toughest part of the competition, and it's over. Okay, now it's time for the live presentations. First team up is team 1966-1, Team Luke Andrews.
I just want to check that everyone can hear me.
Yep. Just give us a minute, Luke. We're gonna we have to move everyone off the stage. Yeah, I forgot about that part. But yes, I believe you are all set. So just give us a minute to get organized. Yeah, and just as a note to the rest of the teams, to try to avoid some issues we've had in the past, we just want to hear your mic and confirm that everything is good before we let you start the clock. So yeah, you don't need to be too anxious because we're going to be doing some brief checks before you actually start.
We are all set. All the teams have been moved except, oh, one more, hold on.
Yeah, I think that was my mistake.
It's okay. All right, so now going forward, I believe Pam is going to start going to help me move the teams out, and I will move the next team in. So that's how that's going to go after this next one. So.
Okay, and the timer is ready.
You got my team number?
There we go.
My name is Luke Andrews, and I would like to present my robotics positioning and orientation system. In robotics competitions, one of the biggest challenges is trying to figure out where your robot is relative to the surface. This is normally achieved using tachometers or gyroscopes, but I have found them to be inaccurate. For example, if the robot's wheel slip, the tachometer's measurement could be inaccurate. If the robot gets bumped, the gyroscope's measuring could be inaccurate. A magnetometer can be used to realign a gyro. However, if there are other magnetic fields, this can disrupt it and also cause it to be inaccurate. Often robots are required to follow edges and lines in order to orientate themselves, but this is a slow process. If one could know your robot's position, you could move directly and much faster straight to the point. I built and programmed this prototype, which uses two optical computer mice to tell where the robot is in real time. It does this by combining the mice inputs with calibration data in order to determine its position and orientation. I also programmed the graphical interface as you can see on the screen. So the orange area is the surface, which is drawn from calibrated area values, and the green area is the robot. On the four corners of the robot, there are boxes which represent the distance sensors, which show when it goes over the edge. Now, the graphical interface allows the user to see where the robot is in real time, or even to step through movements that just happened using a gaming controller. All sensors without a fixed reference point will drift over time. I have compensated for this by integrating a set of rules into the program, which automatically adjusts the position and orientation of the robot based on data from the four distance sensors. When they detect an edge, it will automatically adjust it. I now want to demonstrate. So the first thing I want to demonstrate is starting at a known position at a known orientation, home base. So if I take it and I move it around, you can see it knows where it is on the screen. Move to that side, back corner, Now, if I do a bit of a spin, you can see it shows its orientation. Now, the second thing I want to show is what happens when it's off. So this is an extreme case, but I'm going to put it in the middle of the table and put it at a bit of an angle and reset the position. So now, according to the program, it thinks it's at home base, but in reality, it's at an unknown position and an unknown orientation. So now, as it goes along, and maybe it goes along this edge a little bit, and now the more edge events it gets, the better. But as it goes along the edge, it'll start improving the angle. So they've just adjusted the angle. And now if you go to another edge, it'll start adjusting its position a little bit better. But since this is an ongoing process, the more edges you go to, the more it will adjust. Now, if I bring it back to home base, since it was an extreme case, even now it knows where the robot is, it's at home base. This really shows the effectiveness of the corrections. The next step would be to miniaturize the prototype so that it can be used in robotics. So this is you only need 2 mice sensors. This is the size of a mouse sensor. It's just smaller than my hand. And at least 2 which you put anywhere on the robot, and then some processing in order to interface with the robot. This innovation has exciting potential in revolutionizing autonomous navigation, not only in robotics to know where your robot is relative to the surface, but in broader applications, such as in factories, where robots take parts from place to place, or even in more complex scenarios, such as on a ship, where the surface that a robot operates on can change orientation. Thank you.
Thank you. Very nice. Okay, I think our timer is ready. Who has questions?
Hi, Luke. I do. Yeah, sorry. Yeah, I do have a question. Not questioning, but really curious. How do you come to this topic? I mean, this is really fundamental challenging point for robotics in general. I mean, so how do you come up with this topic or point?
So actually, last year when I entered the game, I started using, I'll bring it a little bit closer to the camera, but I started using a mouse like this at the bottom of my robot. Now, it wasn't very complicated, but it allowed me to tell kind of where my robot was on the surface. And from that, this year I thought, well, why not take this and develop it further, since it proved so useful last year as a sensor, as a part of my program that was really fundamental.
I think David Carberry has a question.
Could you talk about what processor is used and the software or programming language that's used?
Cool. So it runs off a Raspberry Pi. Obviously, the mice have their individual processing, but everything runs off the Raspberry Pi. The graphical interface runs off my laptop because it's not really part of the program. The actual processing happens on the Raspberry Pi. And then I use Java, since that's what's going to be, I'm going to be using at school. But it probably would have been better to use something like a Python. So I'm planning on moving some of my parts of my program onto Python, as I think it would be more beneficial in this type of situation. But currently it uses Java. And I obviously also use a lot of R in terms of processing the data.
Does this robot require to does it need a map of the area that it's like working in before it goes into it, or can it develop the map while it's in there?
Okay. So what happens is, before you have, I think what I call a calibration. So basically you calibrate the area of the surface. So currently it only works for square or rectangular surfaces. And basically I start at home position and then I go and I map out the field by going to the 4 corners. But then you also get another part of the calibration in order to determine, for example, the distance between the mice, the angle between the mice, the position of the 4 distance sensors, and so forth.
Okay, I'm sorry, but time is up for the question and answer period. I know we still have some hands raised, so judges, please make note of your questions and we can follow up after the competition. So Luke, thank you very much. Very impressive.
Thank you so much.
Okay, next up is team 3706-1, Power Puff Nerds. Are we missing a camera still? No, I see it.
Okay, so is it clear?
You're sideways. Your image is not horizontal. Yes. Okay, good. Okay, did you want your other camera on too or no? Okay, good. Yeah, we can see. Okay. All right, you want to do a quick sound check?
Okay, is it clear?
Yes. Oh, one more time.
Hello, can you hear me?
Yes, I think we're good. Okay. Okay, timer's ready. Okay, go ahead when you're ready.
We're ready. We are power partners from Saudi Arabia Gifted Schools. At the beginning of our project, we looked at some environmental issues, specifically in soil. We found a variety of topics as zinc and iron deficiency. Our project topic is the study of zinc and iron effect in the soil and wheat crop. Our main goal is to preserve wheat plant nutrition. So why did we choose this plant type? Because it's one of the most important sources of energy in Saudi Arabia.
During the research, we thought about how to use technology to solve this project problem, and therefore we designed and programmed this robot to solve it. Okay, so as you saw, the process we invented started with the robot taking samples from the soil and then allocate its area, then deliver it to the first lab. In this lab, both zinc and iron that are soluble in the soil are being measured. And here we got two cases. Either if the measurements were standard, then the robot would be looking for another area to test it, or if it was below the normal average. In this case, the robot would be looking for a metal waste using sensors. Then take it to the second lab using electric magnets. When it's approached to the second lab, a compound of two magnet fields are going to take the metal waste to the reaction room. It's an electrical medium with IPMC chemical compound and the metal waste. In these conditions, the metal waste will start to polymerize, and here comes the lab specialist duty. He will be determining the added amount of zinc and iron to the soil according to the data we had from the first lab.
The problem, how does the decrease of zinc and iron quantities affect the human's health? Our goal is 1, improving wheat crop, 2, employing technology into solving environmental issues, 3, saving the environment by recycling metal waste, 4, using physics and chemistry application into solving environmental issues, and 5, achieving our country's vision, the vision of 2030, which is built on 3 pillars: a thriving economy, a vibrant society, and an inclusive nation. In our project, we hope achieving our country's vision by a thriving economy. Our hypothesis, assuming that the soil can be fed metallically by interactive IPMC with metal in the electric area.
And now we have a presentation that just to clarify some points and ask some questions you may be curious about. We have mentioned before the normal average. What is the? These are the normal average for zinc and iron in the soil.
Our country's vision, like I said before, is built on 3 pillars: a vibrant society, a thriving economy, and an ambitious nation. So the wheat growth statistics in Saudi Arabia, here we can see clearly that the wheat growth in 2016 is less than 2015, and this change is caused due to the lack of iron and zinc quantities in the soil.
And here is a 3D model to just to clarify the idea and how it looks in real life. And thank you for listening.
All right, thank you. Okay, who has questions?
I was curious what testing and iteration you did on your robot design.
Our study is certificated by specialists in chemistry.
What was the most difficult part of your project, and how did you address it?
Founding, I think the references, we had to take our information from trusted sources.
Okay, I think we have a question from John.
Hi, what was your, the slides were helpful. What was your motivation for wanting to look at a project like this?
Because we're trying to reach our country's vision, like I said before, the vision of 2030. And it's kind of helped our vision and in a thriving economy, like I said before.
Because wheat is really important in our economic base.
Oh, Ben, you have a question?
Yes. With regards to the data you just showed between 2015 and 2016, do you have any explanation or insight as to what changed in terms of what caused the change in the wheat production?
The lack of zinc and iron are going to make the wheat growth less.
Okay, so incrementally, do you know what that relationship was in terms of the lack of zinc? What happened to the lack of zinc, I guess, is what I'm really trying to get at here and asking. Do you know what happened to the dissipation of that compound?
Soil pollution.
Yeah, soil pollution.
Okay, so, and very good. So then it was a soil pollution that caused reduction of zinc that caused a reduction in wheat production, correct? Okay, thank you. Excellent.
All right, thank you. It looks like we're out of time for the questions, but thank you very much. Yeah, Powerpuff nerds, well done. Thank you. Okay, next up we have team 3004-3, Ecotec One. Okay, looks like the camera is sideways again. The second camera.
Here we go.
Okay. Can you get it? Yes, there you go. Okay. All right. Should we do a quick sound check? Sound check, is it good?
Can you hear me?
Yeah, sounds good. Okay, timer. I think timer's ready. Whenever you're ready, you may begin.
It's right over there. Is
it showing on the screen?
Yes. I think. Yeah, it's right there. I see it. It is. Ready? 5, 6, 7, 8. Hi. We are Team Ecotec One. We are here to present the COVID-19 rover. The COVID-19 rover is an autonomous rover that will humidify the air in hospitals and other high traffic areas.
Hi, my name is Jill Nelson, and I'm the General Statistics Researcher for U.S. healthcare workers. In the U.S., medical workers have a 12-to-1 ratio. Medical workers have a higher infection rate than non-medical workers. Thank you.
Hello, my name is Dora Beasley. I am General Hospital and Bacteria with Virus Researcher. Coronavirus is a virus that affects humans and animals. Typically infected upper respiratory infection. Now I have an example of how coronavirus passes onto each organism and how to be affected by it. I have a pH indicator that detects coronavirus.
Hi,
researcher. Hi, I'm Brianna Shepard. I am a general hospital researcher. An environment that is kept at 40 to 60% humidity level decreases the transmission of a virus by 30%. Here again, an environment being humidified. Here, the humidity is at 63%. The humidifier has 3 modes: this mode, this one, and this one.
Hello, my name is Victoria Hackett, and I am the lead engineer. This is our code for our rover. This first part of the code says that when the middle line tracker senses black, it goes forward. When the middle and left line tracker senses black, it turns left. And when the middle and right line tracker senses black, it turns right. And this is the code for the ultrasonic rangefinder, just stating that when the rangefinder senses an object in a certain distance, it will stop. This is our rover. This rover, under here are the 3 line trackers that use infrared sensing to tell whether how light or dark the line is, so that the rover can follow a black line on a white surface, so hospitals can customize the track to any layout they want. And here's the demonstration of our rover.
The left line tracker saw the black line, so it turned left. When the ultrasonic rangefinder see a transparent object, it stops.
And when the ultrasonic rangefinder see this opaque object, it will also stop. And when you remove it, it goes forward, and then it will turn to the left. It will turn to the left, and it will keep going.
Can you see us?
Yes.
That concludes our demonstration. Thank you. Any questions?
Okay. Thank you very much. Okay, looks like we have a question from David Carberry.
Good morning. When the robot stopped, it looked like the humidifier kept running. Does the robot actually control the humidifier, or is that just manually turned on?
It's manually turned on. We hope in the future to get the brain of the robot to control the humidifier, but we could not do that, unfortunately. So, yeah.
Okay, looks like we have a question from Wei Liu.
Yes, I see that you have a quite a big team. This is, very good. 5 members. I'm just curious, how do you cooperate the team activity during this very special environment, COVID-19 environment? How do you arrange your team, activities, all these kind of things, coordinate the team members, workload, share all this project? Can you give us a very brief description?
Yes, so we did most of our research. For the research portion, we did Zoom meetings online, so we did not have to meet together. And then while we were in the lab, there's only 5 of us, so we can still practice social distancing while we can. We kept masks on while we were working on the project. And that's pretty much it.
That's great. Thank you.
Thank you. Okay, looks like John has a question.
With your robot, were you able to actually sense humidity? You know, to David's question about being able to control humidity, high, medium, or low, can you sense humidity also?
Yes, we were able to. We have a sensor that we were using that we have under we have a digital sensor for humidity.
Okay, so you would be able to sense it and then control it on and off.
Yes,
in a future project.
Right, but we could not control the humidifier to the brain. So, but we plan to do that in the future.
Okay, okay, thank you.
Okay, looks like that's it for the time for question and answers. Thank you very much, Ecotec.
Thank you.
Okay, next team up is team 3346-1, Chen High Technology Space Pioneer. Okay, can we do a brief sound check?
Hello.
Okay, sounds good. Okay, you may begin when you're ready.
Okay, you may 1, 2, 3, go.
Hello everyone, we are Channel High Technology Space Pioneer. Our team leader is Christy. Hello. And our team members are Ben, Toby, Paco, and me, Rosa. So we are going to show our AD tunnel, which is a transportation system designed for safety reasons, both for transporter and the pedestrians. The AD tunnel emits red or green light. When there is red light, the color sensor on the transporter gives signal to the EV3 and the transporter stops. At the same time, when there are pedestrians, they see the red light and they will notice that something dangerous just happened. When there is green light, that means both pedestrians and the transporter will move normally. So let's talk about the technology we use. We use the controllable LED lights to control the lights on or off by using the Arduino board. For the rocket transporter, we use the EV3 color sensor to detect the brightness of the AD tunnel. So here we have an example showing the above technology. This is a demonstration of the rocket assembly and launching process. In the AD tunnel, you can see the rocket transporter. It keeps moving until it arrives at the assembly station 1. The ultrasonic sensor at the assembly station 1 to detect the arrival of the rocket transporter and trigger the movement of the robotic arm. The first assembly procedure begins. When the laser beam emitted by the laser sensor being blocked by the rocket transporter, that means the assembly procedure has been completed. The laser sensor then activates the program of the AD tunnel. The rocket transporter will move again when the red light of the AD tunnel goes out. The rocket transporter stops again when it arrives at the assembly station 2. The assembly procedure used at assembly station 1 will be repeated again. The rocket transporter finally arrives at the launching area. It gives signal to the ultrasonic sensor at the launching area and triggers the program of the rocket holder. The door of the rocket holder closes and the rocket transporter leaves as the light of the AD tunnel turns off.
好，2分鐘。閂到。搞個火箭啦，火箭板都唔好啊。
Then the countdown board starts counting down. After 5 seconds, the door opens and the rocket launches. So next is Paco's turn.
Hi, I'm Paco. Let me explain the operation of assembly station 1 and 2. There is an ultrasonic sensor under the assembly station. When the rocket transporter is detected with a 15 cm, the program in EV3 is charged. The robotic arms will put the second part of the rocket on the rocket transporter within 7 seconds. When the assembly procedure is complete, it will block the laser beam emitted by the laser sensor. The laser sensor gives the signal to the Arduino board. The rocket transporter keep moving forward. The rocket transporter arrives at the assembly station 2, and the procedures repeat. It is your turn now, Toby.
Hello, I'm Toby. Let's talk about the countdown board and the launching area. The countdown board is made of a wood board, LED lights, and ping pong balls. The launching area is built with Lego, which is includes models and an ultrasonic sensor. When the rocket transport put the rocket into the launching area, the ultrasonic sensor will trigger the program, and the door will open. Then the countdown board will count down for 5 seconds. This is the end.
So this area is the main point of our product. So yeah, this is the end of our presentation.
Thank you.
All right, thank you.
Thank you.
Okay, I guess we can start with Mr. Carberry. David, you have questions?
It looks like there are many processors. Could you talk about how many processors and what type are used on this project?
Five. There are 5 of them.
解釋啊，係啊。
你用咗幾多個
微型電腦？
呢個係都係一個。So this is the rocket transporter, and it and it will transport the rocket to the launching area. And the second one is the assembly station 1. It has the second part of the rocket on it. And the third one is the assembly station 2. It has the last part of the rocket on it. And the fourth one is the launching area. It sends the rocket, and there it will launch the rocket. And the fifth one is the countdown board. It will count down 5 seconds for the rocket to launch. And the most important thing is the LED tunnel. It
is controlled by LED灯.
It's controlled by the LED lights, and the rocket transporter has a EV3 color sensor. So yeah, that's it.
Okay, I think Wei Liu has a question.
Oh yeah. So you have many controllers. I saw you have Uno and you have multiple EV3. How do they communicate with each other?
So there's a EV3 color sensor on the rocket transporter, and the color sensor will sense the color on the LED tunnel. So if the LED tunnel light is on, then the transporter will move forward. But if it's red, and it will stop. Yeah.
Okay, John, did you have a quick question or? Ben?
Yes. Real quick, so it looks like a lot of this is based on the sensor architecture and the status of the sensors, okay? With regards to the core software for each of these processors, was that something you put together yourselves, or was that something that came packaged with the microprocessors?
We made it all by ourselves. Like
Okay.
the lights and stuff. Yeah.
Okay, so then the code, you actually wrote the code, or where there was a specified software for each of the processors? Like, so is the software code the same for all of the processors, or do they each have their own separate type of language?
嗰啲控制器嘅語言係全部一樣嘅，定還是係每一樣控制器都有自己語言？有兩種語言，一個係 Arduino 嘅語言，一個係英文答唔該。
So one is the Arduino board, and the second one is EV3. Yeah.
Okay. Thank you.
And the Arduino is for the lights of the
Use the C language. C. ABC 嘅 C language.
Use the C language.
Okay, excellent. Yeah, I'm very familiar with Arduino and Raspberry Pi family or class of processors for this type of application. So good to know. Thank you.
Okay, thank you. It looks like we're out of time for questions, but thank you very much, team. Well done.
Oh, you're welcome.
Thank you.
Okay, our next team, team 3385-5, Echo P3.
Hi, welcome to the Robofest 2020. We are students from the high school number 3, and probably we are from the Autonomous University, Populares State. We are from Mexico, and the team is conformed by
Andrés,
Jocelyn Umbral,
Aldo Sánchez,
and I, Brian Rubalcaba. In general, our project is capable of classifying the different solid waste.
Our project was born before for the problem of pollution and the little waste treatment. Solid waste represent a constant problem for the environment and the public health. So we decided to create this prototype because in Mexico and the world have a problem to classify different solid waste. In Mexico, 43% of house or homes classify different waste. So this prototype create a conscious and create a culture to classify different solid waste. For example, in our school, in our high school number 3 has an ecology and sustainable project that for this reason create a prototype that are in the high school for in a community for 2,100 students.
Derived from the above, we established a relationship of the functional electronic with the ecology, and we also verify the importance of the environment preservation and the relevance of classify the different solid waste like a lifestyle.
We create this project using different types of sensors, which are sound, inductive, capacitive, and infrared. Having the sensor, we decipher multiple types of combination in the sensor to know what type of residue is being detected and thus correctly differentiate between similar material, such as, for example, to differentiate the glass from the plastic, we only use the capacitive sensor and sound. Since the plastic do not have conductivity, instead the glass if it has conductivity. This type of combination helps you to correctly define and classify waste.
The production cost of our prototype is 1,800 Mexican pesos or $19. Our prototype have two versions. The domestic version were with electrical power and the public version were with solar energy. The prototype was 6 hours or 8, depend of the using.
Some advantage of this project is waterproof and has the capacity to support 8 kilograms. Sometimes it depends on the volume of each material. Obviously, we can increase this dimension, but other use.
We are using multiple types of combination in the sensor to know what type of residue is being detected and thus correctly differentiate between similar material. For example, for the metal, we are using the inductive sensor and capacitive sensor. For the glass, we are using the sound sensor and capacitive sensor. For the plastic, we are using the sound sensor and infrared sensor. And finally, the organic material, we are using the capacitive sensor.
We finished this presentation.
All right, thank you very much.
I'm curious if your product works with pieces of material that aren't in the shape of a bottle, and if not, what changes would you make to your product to handle those kinds of materials?
We differentiate the plastic and the glass with a sound sensor. Each material has different decibels, and we use a sound sensor for different each materials. And we use this part for different.
To differentiate the glass from the plastic, we only use the capacitive sensor and sound sensor.
I'm curious about different shapes of materials. Like if you had like a trash bag or something, could you deal with that, or would you need to change your product in some way?
We can use different type of trash cans. We have different versions. this is the domestic version and it is very small. For the public version, we can use solar energy and we can increase the dimensions and the structure.
Thanks.
Is there a reason that you, are you prioritizing like cans and bottles? Is that why it's shaped the way it is?
We only classify the solid waste and we can classify the uniform materials.
Okay.
How does this work if you have like a takeout container that's styrofoam with maybe put a pot can inside of it, like with mixed materials?
Can you repeat the question, please?
If you were to throw something out, say you have a takeout container with that styrofoam and you put a pot can inside of it because that was like your lunch and you're throwing it out, how does your product handle that?
For the future, we can increase the materials. We can add paper and the box and other materials. We can increase these materials in this project and trash can.
Yeah, I think the question is if it was mixed, if it was part one material, part the other, is there a priority? Does it handle, how does it handle it?
The principal material for classified is the plastic because it's the most important material in the world.
Okay, okay, thank you. Okay, looks like we're out of time, but thank you very much. Well done. Okay.
We are Eco-Petroleers.
Yes, thank you. Okay, next up is team 2656, Garda. Okay, when you're ready, I would like to do a brief sound check.
On my other laptop.
Yep, take your time.
Okay, so hold on.
Okay.
Okay, wait, I'm ready. So I'm gonna screen share from my laptop, but use the mic.
Right, yeah, I think we've got that. Okay, you may begin when you're ready.
Okay, I'm gonna screen share real quick. Is the scene?
Yes.
Okay, so my name is Euphoria Cunnin, and I am team 2656, and my presentation is Project Garda. So some of the challenges of COVID-19 is, COVID-19 is a highly infectious disease, and it's caused by the most recently discovered coronavirus. Human handling of test samples can increase the infection rate and spread of the coronavirus, and delays in test results are generally tied to delays in testing and test sample deliveries. Most tests are delivered locally by car or truck, and traffic can cause even more delays. Finally, labs struggle to meet the demands due to unpredictable surges in cases. If staff was transferred from the transportation field to helping out with tasks to help lab professionals, it would be a much more efficient approach during a pandemic. A possible solution for these issues is to use drones. So here's my drone that I built. It's a standard DJI F450 frame with a Pixhawk flight controller. And the Pixhawk is powered by a LiPo battery, and the battery also powers the PDB, which in turn powers the ESCs and motors. And you can see this connection diagram on the left. The Pixhawk also sends out output using wire cables, and the Raspberry Pi is powered by a rechargeable battery. And the reason for this is because of the inability of the 5-volt GPIO pin to maintain a steady voltage. And the Raspberry Pi communicates with the Pixhawk using the GPIO pin and the serial telemetry ports that are actually on the Pixhawk itself. The LiDAR on my drone is powered by through the LiveVox power cable, and it's soldered to the PDB. And it uses an Ethernet connection to my Raspberry Pi to use a static IP rather than DHCP protocol. That way I don't have to use an external router to send the point cloud data back to my Raspberry Pi. So here's how I interfaced my Raspberry Pi with the Pixhawk. As I mentioned earlier, I used the telemetry 2 port on the Pixhawk to the GPIO pins and Pi, and that's shown in the diagram on the right. However, because of the inability of the 5-volt pin on the Pi to keep a steady voltage, I use a portable charger to power the Pi from the micro USB. I can find the Raspberry Pi's IP address using the command sudo nmap-sn with the IP address, and the 0 to 24 search range, it range searches from 0 to 255 of all the IP addresses. And once I'm able to find the IP address for the Raspberry Pi, I can simply use SSH or Secure Shell protocol, and that allows me to access any directory or file and run it directly from the Pi, which allows me to run both my autonomous program and LiDAR capture program. So DroneKit is a Python package that I use to fly my drone autonomously. It can connect to the Pixhawk using MapLink and then listens on the specified port. So all I do is type in the port using argument parser, and it's able to connect and then run any script. For example, the script on the top right shows it that it's going to fly to a certain altitude, and once it reaches that 95% of that target altitude, it just goes back down and lands. So here's how I integrated my LiDAR with the drone. I'm using a LiveVox Mid-40 LiDAR, and it's powered from the PDB on my drone, as I mentioned earlier, and it's able to map out environments, and I use it for both mapping and hopefully for navigation. I'm able to use the OpenPy LiveVox library and force my Raspberry Pi and sensor to predefine static IPs. And all I have to do, as I mentioned earlier, is connect using one Ethernet connection, and I don't need to use any additional routers. Essentially what my program does is it starts a data stream, captures the binary data, closes the data stream, and it converts this binary data into a CSV file. And then using that CSV file, I'm able to generate a point cloud sample of my environment. After receiving the binary data, I bind the X, Y, Z, and scalar values and wrap them in the Cloud Compare software, which I'm going to show you. The LiDAR is able to find the distance between objects and recording the time it takes from the lasers being sent from the sensor and time when they return. Putting all this data together creates a 3D point cloud model that can full environment. So here are some of the point cloud samples. Oh, it's on. Okay. So is my Zoom. So here is my program. It is going to essentially.
We're out of time. Can you wrap it up quickly?
Yes. So when I grab the LiDAR data, all I do is switch to the Cloud Compare software and input the CSV files, and that allows me to see a point cloud model. And as you can see, this is right outside my house, and it just moves the. You can see a 3D model of the sample.
Okay, I think we're out of time.
Okay.
Okay, but thank you. Yeah, I think it's time for questions. David?
The presentation seemed pretty good, but it seemed like it was missing a physical demonstration. Is there a reason for that?
I have the drone right here, and I was about to show the LiDAR and physical demonstration, but I think I did run out of time a bit. But I have essentially, I can't fly the drone inside of the house because there is a ceiling, and I can't really, since it's virtual, I can't like fly it inside of the house. So that would be I do have videos of it flying, which are included in my document that I've submitted previously.
Okay, Ben?
Yes. So noticing from your software, you use Python, okay, and then you use certain protocols, okay, for communication in lieu of adding additional hardware. With regards to that, in terms of the actual software for those protocols, okay, to communicate from one to the other, what is your source for that? Did you do that, or did some, or was that a packaged software?
Well, are you talking about the protocols, for example, for the LiDAR to the Raspberry Pi, like the DHC? Yes. Essentially, these are just how, so essentially how Wi-Fi works and like Ethernet connections work. When you have like, when you're trying to use an Ethernet connection, you can either use it through a router or directly to a separate thing. So my LiDAR has its own IP, and it can be either a dynamic or a static. And so when I set it to, it generally comes as a dynamic IP. And if I was to use the dynamic IP, I would have to use a router and then connect my Raspberry Pi to the router also, and it would use a dynamic, it would use the DHCP protocol.
Right. So you did it with the router though, correct?
Right. I am able to force the LiDAR to a static. I originally did it with the router, but now I don't need the router because I was able to force my LiDAR to a static IP. Therefore, I can connect that Ethernet from my LiDAR to the Raspberry Pi over here. It's going directly from here to here. And that eliminates the need for the router to be used.
Okay, very good. Very good. Thank you.
Okay, looks like we're out of time for questions, but thank you very much. Okay, I think we have one more team. Team 3713-1, homies. Yeah, I think we have to do a couple confirmations to make sure they're going to be connected.
Okay, so tell us when do we start at the timer. First thing, is our voice clear? Can you hear me well? Or should I raise it? Is it good? Okay.
Yeah, your second camera though, is that, were you going to use your second camera?
Is it okay? We are now going to the second camera because we realized that we don't need the screen sharing and it's going to take up too much time.
Okay. No, that's fine. Yeah, okay. Okay, if you're just going to use the one camera, that's whenever you're ready, you can start.
Okay, hi, Assalamu alaikum. I'm Andrea Meister, and this is my teammate Samah Nassar of Homes team from Saudi Arabia. Today we will present our project, Distinguishing Faith Times in Makkah using executive programming language. Our project will benefit 1.9 billion Muslims, whereas focuses on prayer, Salah, which is the most important pillar of Islam. The special part about our project is that we changed the use of EV3 blocks. We used to use it as something to connect motors and sensors together as the brain. Now we actually put programs in it and we use it as an application that we can use in many fields. So our project actually divides into two parts. The first part is it's a mosque-like system which shows a Muslim man praying, and then it talks about how much time is left for the next prayer. Then when you press the middle button again, it shows you a feature when you can, is it clear? It shows you a feature where you can change times, hours, and days, so you can know when it's the time for prayers daily since it changes. Now we're going to give you an example of our Fajr prayer.
As you can see, as soon as the Adhan started, which is a call for prayer, the light of the tower of the mosque lit up. This is because we actually want people who are short of hearing and deaf people to know that it's time for prayer as well, so all Muslims can pray on time. The second part of the project is prayer timing, where it's showing cases of prayer timing and including the prayer change. Now it also shows that we can change time of prayers daily depending on where you are. There's three options here. There's the prayer timer, which shows us the prayer times for each day, and you can also go down and up, and it shows you each and every one. And then there's the other option, which is the dhikr, which is something Muslims say in order to seek forgiveness or to praise Allah. So you can also do that, and it keeps track of how many dhikr you said, depending on which type you want to use. Now, we also talked about that the salah times change, but we never said why. The phenomenon is caused by the slight shifts in Earth's rotation due to its ecliptic orbit. This happens because Earth's speed changes whenever it's close or away from the sun, which causes the times of day from dusk till dawn to change, and so the times of the prayers. Then we actually faced an obstacle in our project, which was at the programming, which was that when we were entering the times of prayers, we needed to manually edit them daily. But then we added an adjustable counter that users can change once when we start using the program, and then it can automatically calculate the difference of change in numbers and days times of the salah. Finally, we can say that our project will revolutionize the way we use EVT technology and will aid us reach new horizons in application creating. Thank you. We are done. Is there
Okay, thank you.
So my teammate doesn't speak fluent English, so if there are any questions, she will try to answer them. And is it okay if I translate some of the questions to her?
Yes, that's fine. Yes, no problem with that.
Ask questions.
Okay, I think the timer's ready. Judges, do we have questions?
Hello. I noticed that in the beginning you were entering the time manually. Would there be a way for you guys to obtain the time somewhere so the user's not inputting the time every time they start the robot?
The manual time, you don't need to actually put it every time you start the robot. You only need to put it once, so you can select the time of your domain. Like you can say what day it is of the month, what hour it is, and what minute, and then the program will automatically calculate the difference of change in time and the salah times.
Thank you.
Okay, John?
What were you showing on the iPad? I missed that. Was that the placement of the sun?
Yes,
location of the sun?
It shows that the place of the sun changes monthly, like it shows the change, the monthly change in position of the sun daily, and that affects the solar times, as I said, because of the orbit of Earth around the sun and the speed of it. So that causes the prayers to change, and this is the main reason we made the project, so we can calculate the change and everybody can know it, so they can pray on time.
And you're looking at time, but are you also looking, do you have an optical sensor looking at sun placement?
We actually, we made a setting in the program that it calculates a pattern of the change in time based on the change in movement. And then it can adjust the days and times depending on weights. Like there's a weight that calculates half a second, and then the seconds go up by 60, and then the minutes change, and so on. And when that happens, it can show which prayers are due on which certain time.
Okay, I understand. Okay, thank you.
You're welcome.
Okay, are there any more questions? Okay, no, it looks like it's okay. All right. All right, thank you very much. Well done. Okay, I think that was our last presentation. Yeah, thank you very much, all teams. Yeah, these live presentations are a challenge, and you've all done very well. I know it's a lot of preparation. Yeah, a lot of work for just a few minutes on screen, but thank you very much. Results will be announced at the Robofest Online World Championship closing ceremony on Saturday, October 17th. So please join us for that. So at this point, it's time for our closing. I would like to introduce Professor CJ Chung.
Thank you, Elmo. Hello, everyone. I am CJ Chung, Professor of Computer Science at Lawrence Tech. I was lucky to start this Robofest 21 years ago. Thank you so much for being a part of today's exhibition competition. I'd like to thank all the coaches, mentors, parents, and volunteers. Without you, especially at this unprecedented time, this competition is not possible. I also commend all the students for their excellent projects today. Thank you. Today, we had a fantastic panel of judges. Mr. John Arnold, Mr. David Carberry, Mr. Ben Gonzalez, Dr. Wei Liu, Dr. Yanlu, Professor Wu Mingjing, Mr. Morgan McCann, Miss Andrea Meister. Thank you, judges. Lastly, I give kudos to Robofest staff. Mr. Santos, thank you. Miss Peloris, Miss Sparks, and Mr. Oliver. Robofest is all about STEM plus computer science learning. In addition, we also focus on the learning of 3 soft core skills. They are problem solving, creativity, and teamwork, PCT. I believe this online exhibition event is a perfect example of exercising a global teamwork all together. Thank you, everyone, for being a member of this global team through Robofest. See you at the closing and award ceremony on October 17th on a Saturday morning, and or afternoon or evening. I wish everyone stay safe, stay learning, and goodbye.
Thank you.
Thank you.